What if we've been asking the wrong question about AI? For years, we've treated AI as a machine for prediction. Predict the next word. Predict customer behavior. Predict the future. But prediction is only part of intelligence. Real intelligence is about making decisions. Decision trace model begins with a simple idea. AI is not for prediction. It is for decision. Over the past few years, AI has evolved at an extraordinary pace. We now have ChatGPT, retrieval augmented generation, AI agents, the model context protocol, and increasingly powerful search technologies. Every few months, new capabilities emerge. Yet one important question remains. Have these technologies truly solved the challenges that organizations face? Information is easier to access. Knowledge is easier to generate. But better information does not automatically lead to better decisions. This is where decision trace model begins. Every company already has knowledge, documents, manuals, reports, databases. Many organizations also have RAG systems. And today, they increasingly have AI. But eventually, every project reaches the same question. What should we do? Not, what information do we have? Not, what can AI generate? But, what decision should we make? That is why knowledge exists. Knowledge is not the goal. Knowledge exists to support decisions. And once we understand this, we begin to see AI from a completely different perspective. As AI becomes more capable, a new question emerges. How should we connect AI to real-world systems? Today's AI can write code, generate reports, conduct research, and even act as autonomous agents. In many cases, AI can perform almost everything, up to the moment before execution. But connecting AI directly to business operations is risky. AI may misunderstand company policies, interpret exceptions incorrectly, or make decisions beyond its intended authority. The solution is not to limit AI's intelligence. The solution is to design the connection properly. Let AI support decision-making, but keep execution under clear human and system control. Define boundaries. Define responsibilities. Build trust into the workflow. That is the core idea behind the decision trace model. So, what exactly is the decision trace model? The decision trace model, or DTM, is a runtime architecture that connects AI to the real world safely and responsibly. AI is powerful. It can analyze information, generate ideas, and recommend actions. But the real world is far more complex. It contains people, organizations, policies, responsibilities, and risks. DTM introduces a structured runtime between AI and execution. First, it receives events and signals from systems or people. Next, it understands the context using available data, intent, and history. Then, it evaluates boundaries, checking rules, policies, roles, and potential risks. If necessary, the decision is escalated to a human for review. Only after these checks does the system execute the decision with clear ownership and accountability. Finally, every decision, every action, and every outcome is recorded, creating a continuous feedback loop for learning and improvement. In other words, DTM transforms AI from an isolated intelligence into a trusted runtime that can operate safely in the real world. Now let's take a closer look at the DTM runtime. Think of it as the execution engine that transforms AI output into safe and responsible actions in the real world. The process begins by receiving signals. These signals may come from AI, business systems, sensors, or people. Some are obvious. Others are weak signals that may indicate important changes. Next, DTM builds relationships. It connects people, events, documents, systems, and history to understand how everything is related. Once those relationships are established, DTM interprets the context. It asks, what is happening? Why is it happening? And what background information should be considered? After understanding the situation, DTM evaluates boundaries. It verifies company policies, business rules, regulations, available resources, and potential risks. Not every possible action is an acceptable action. For critical decisions, DTM can escalate the case to a human decision maker. Human judgment remains essential whenever responsibility, ethics, or uncertainty cannot be delegated to AI. Only after all necessary checks does DTM authorize execution. The decision is carried out with clear ownership, clear accountability, and a well-defined scope. Finally, everything is recorded. The signals, the reasoning, the decision, the execution, and the outcome. These traces become organizational knowledge, allowing every future decision to become smarter than the last. This is why DTM Runtime is more than an AI workflow. It is a runtime architecture that combines intelligence, governance, human responsibility, and continuous learning into a single trusted system. So far, we've explored the concepts behind the decision trace model, but DTM is more than a theory. It is being built as an open source ecosystem. At the center of this ecosystem is the Decision Runtime Core. Think of it as the operating kernel for decision making. It evaluates signals, understands context, enforces boundaries, invokes human approval when necessary, executes decisions, and records every step as a decision trace. Around this runtime, specialized modules provide additional capabilities. The interaction module receives conversations and user input. The decision model defines decision rules and structures. The decision trace ledger stores immutable decision histories. Visualization modules allow people to inspect and understand decision traces. The multi-agent orchestrator coordinates multiple AI agents working together, and the learning module uses past decision traces to continuously improve future decisions. Together, these modules form a complete decision-making platform. From interaction, to execution, to organizational learning, our goal is simple: to build an open foundation, where humans, AI, and organizations can make decisions that are transparent, traceable, and trustworthy. The decision trace model is not just another AI framework, it is an open architecture for building the next generation of intelligent systems. So far, we've explored how the decision trace model supports safe and trustworthy decision making. Now let's see how it fits into an entire enterprise system. Everything begins with the real world. Data arrives continuously from business systems, IoT devices, quality management, maintenance records, customer feedback, and external regulations. At the same time, people and AI agents interact with the system, asking questions, requesting analyses, and proposing possible actions. All of these signals enter the DTM runtime. The runtime does much more than call an AI model. It interprets signals, assesses risks, retrieves relevant knowledge, applies decision logic, and evaluates organizational boundaries. When a decision requires accountability, the human gate brings the appropriate experts into the process: engineers, quality managers, safety owners, executives, and compliance teams. Together, AI and humans make decisions within clearly defined responsibilities. Every decision, every assumption, and every action is recorded as a decision trace. Those traces become organizational memory, allowing future decisions to learn from past experience. Finally, approved decisions are connected to operational systems, triggering notifications, workflows, tasks, business applications, and external enterprise platforms. The results flow back into the system, creating a continuous cycle of execution, learning, and improvement. This is the vision of the decision trace model, not simply using AI to generate answers, but building an intelligent runtime, where AI, people, and organizations can think, decide, act, and continuously learn together. Let's look at a real-world example from manufacturing. Imagine an electric vehicle manufacturer. Over the past few years, battery technology has improved dramatically. Energy density has increased. Fast charging has become common, and electric vehicles are now being used in hotter climates around the world. These changes gradually increase the thermal load on batteries. Inside the organization, however, people remember that the same design worked well in the past, so the assumption becomes, there has never been a problem. As a result, small warning signs are often treated as isolated incidents: a slight increase in heat, a gradual drop in performance, occasional cooling warnings, scattered maintenance reports. Each event seems insignificant when viewed on its own, but together, they reveal a pattern. The real challenge is not the lack of information, it is the inability to connect these signals, reconsider past assumptions, and recognize that the environment has changed. This is exactly the kind of problem the decision trace model is designed to address. Let's continue with our manufacturing example. Now imagine that small warning signs are already appearing across the organization. The quality assurance team notices that warning reports are becoming more frequent. The field service team finds that maintenance work is increasing in high-temperature regions. The fast charging team observes that real-world usage is exceeding the original design assumptions. Each team is seeing a piece of the puzzle, but these observations remain inside their own departments. The information is siloed. No one connects the quality reports with the field data, or the charging conditions with the changing operating environment. As a result, each issue appears too small to justify action. No single report looks like a serious problem, but when these weak signals are viewed together, they reveal an emerging risk. Unfortunately, organizations often recognize the problem only after a major failure has already occurred. The challenge is not collecting more information. The challenge is connecting information before it becomes a crisis. Now let's see what changes after introducing the decision trace model. A traditional RAG system is excellent at searching information. It can retrieve similar cases, summarize documents, and recommend possible answers, but it cannot determine what decision should be made. Humans still receive the search results, and must decide how to interpret them. As a result, different people often reach different conclusions, and the same mistakes can be repeated. DTM approaches the problem from a different perspective. Instead of simply retrieving information, it observes the decision-making process itself. It detects weak signals, identifies patterns, recognizes historical success bias, and questions assumptions that may no longer be valid. When these conditions are detected, DTM generates structured signals, and asks questions that help decision-makers re-evaluate the situation. For example, are the assumptions still valid today? Has the operating environment changed? Should we consider another course of action? Rather than providing only answers, DTM helps people ask the right questions. That is the fundamental difference. RAG helps us find information. DTM helps us decide what should be decided. Together, they create a decision-making process that is both intelligent and trustworthy. Let's look at the final step of our manufacturing example. As the system continues to operate, DTM continuously evaluates the overall situation. Eventually, the accumulated signals push the risk score beyond the predefined boundary. Notice what happens next. The system does not conclude that an accident has occurred. Instead, it recognizes that the overall behavior is beginning to deviate from normal conditions. This is an important distinction. AI detects the possibility of danger, but it does not decide whether production should stop. When the predefined boundary is exceeded, DTM activates the human gate. The relevant experts review the situation. They consider technical evidence, perform additional tests, evaluate alternative explanations, and determine whether the observed pattern represents a genuine structural risk. Only after this human review is the final decision made. The production line was not stopped by AI. It was stopped because experienced people, supported by AI, recognized a risk that no single signal could reveal on its own. This is the purpose of the human gate. AI identifies situations that deserve attention. Humans make the final accountable decision. Together, they create a decision-making process that is both intelligent and trustworthy. Let's compare the two approaches. In a traditional organization, signals are analyzed separately. Past success creates confidence. Weak signals gradually become accepted as part of normal operations. As a result, the real problem is often recognized only after an accident has already occurred. The organization learns, but it learns too late. With the decision trace model, the process is fundamentally different. Signals are continuously integrated across departments, systems, and time. The runtime evaluates boundaries and identifies patterns that individual teams may never notice. When the accumulated evidence suggests increasing risk, the human gate is activated, allowing experts to review the situation before it becomes critical. Every decision, every assumption, and every action is recorded as a decision trace. Instead of losing experience, the organization builds a reusable knowledge base for future decisions. The result is a shift from reactive problem solving to proactive risk management. The goal is not simply to respond faster. The goal is to recognize structural risks before accidents occur. That is the true value of the decision trace model. It transforms experience into organizational intelligence, allowing every decision to make the next one better. We've explored many ideas throughout this video, but they all lead to one simple conclusion. AI is not for prediction. It is for decision making. The real value of AI is not simply predicting what might happen. It is helping people choose the right course of action for a specific purpose. When decisions are recorded, their reasoning, their assumptions, and their outcomes become organizational assets. Instead of disappearing, they become reusable knowledge. Future teams, can understand not only what was decided, but why it was decided. Through traceability, organizations continuously learn from every decision they make. Each decision strengthens the next. Each experience improves the organization. And over time, both AI and the organization itself continue to evolve. That is the vision of the decision trace model. Not replacing human judgment, but making human and AI decisions transparent, traceable, reusable, and continuously improving. The future of AI is not just better prediction, it is better decisions. Thank you for watching. We've spent decades building better information systems. Today, we are building better AI. But the next challenge is no longer intelligence alone. It is coordination. It is trust. It is the ability for humans and AI to make decisions together. The decision trace model is the first step. By making decisions traceable, transparent, and reusable, we create a trust infrastructure. From trust, we build a knowledge infrastructure, where every decision becomes an organizational asset. Those foundations enable a runtime society, where people, AI, organizations, and autonomous agents can collaborate safely at scale. And ultimately, this leads us to a much deeper question. What is intelligence? Perhaps intelligence is not simply the ability to predict. Perhaps intelligence is the ability to make better decisions together. That is the vision of the decision trace model. Not just a technology for AI, but a foundation for humans and AI to collaborate, to learn, and to transform decisions into lasting organizational assets. Thank you for watching. To learn more, visit chinoba.org.